Hello everyone, welcome to my channel Essentials of Electronics. In today's video, we are going to discuss some basic operation of bistable multivibrator. We are going to check on how this multivibrator is going to generate a pulse. So these kinds of multivibrators are not completely in stable states. This is the basic of this kind of multivibrator. It is continuously oscillating to generate time pulses. I'll move on to draw the circuit diagram of a bistable multivibrator. So here two transistors are connected with back-to-back. Resistors being coupled. The resistor of collector Q1. Let me name the resistors. Yes, so it is shown this way, connected to 0 volts, and let me name this transistor Q1, transistor Q2. Let R1 be the resistor connected to the collector terminal. C1, B1, C1, B1, E1, C2, B2, and E2. Connect one more resistor in the collector terminal of the Q2 transistor. Supply it with plus VCC. Naming, let R1 be the resistor connected to the collector terminal of Q1 transistor. R2 and R3 resistors are the oscillatory components. Let R4 be the resistor connected to the collector terminal of Q2 transistor. Yes. So let us try to turn on the transistors one by one with the help of an SPDT switch in such a manner. SPDT switch with pointing out to two terminals A and B. If the switch is made to close at A, then the transistor Q1 turns on, generating an output at the collector terminals of the transistors. Yes, so now let the output of collector terminal 1 be Q and the output of collector terminal of transistor 2 be Q bar. This is stable in both the states, either with one transistor off and the other is on, or the first transistor on and the second transistor off. Let us suppose that the switch is in left position, that is, it is closed at position 1. Then the base of the transistor Q1 will be grounded and in its cutoff region, producing an output at Q. So here an output of this will be generated at the collector terminal of Q. That would mean that the transistor Q2 is on as its base is connected to the VCC through the series combination of the resistors R1 and R2, which means the VCC. So it is connected in this manner, which in turn Q2 initializes to give an output across collector C1. This in turn gives an output at Q, that is V0. As a transistor Q2 is next turned on, there will be zero output at Q, and the opposite or the inverse of Q will be getting an output. If the switch is now removed from position A and closed at position B. Now Q2 will be turned on. And output will be generated by way of these combination of resistors R2, R3 and R4, thereby pushing an output at the reverse of Q. So here the output obtained will be of this manner. So now by closing the SPDT switch in position A, yes, the voltage will be higher at position A, and when it is pushed at position B, this is the position of the switch at position B. Now the output voltage at Q, so transistor T1 is turned on, and at when the transistor T2 is turned on, when it is moving to position B, the Q output falls down like this. So this is the total time that has been spent in generating a pulse like this. This is the output of the bistable multivibrator. So the instant switch is closed at A, it is time T1, and this instant the switch is closed, the instant the switch is closed at B, this is B, yes, this is time T2. So this is T is the time constant. So what kind of applications we would use this kind of bistable multivibrator? It is used for the performance of many digital operations such as counting and storing binary information. It is also used in the generation and processing of pulse type waveforms. It is widely used in digital logic and computer memory. So these are the few applications of bistable multivibrator. Just summarizing this, when the SPDT switch position is closed at A, the resistors involved are the resistors which are connected to the base of the transistor Q2, collector of the transistor Q2, and the resistor connected to the collector turns on, activates, pushing a pulse at the output of K of Q, and then maintaining in the same position, and when the switch position is removed at A and closed at B, the VCC output falls down when the switch is closed at B, and the same process continues. Thank you.